Hi. I said, hi, kids. Hi. All right, this time, here's what we're going to do. We're going to take the same graph that we did last time when we did it kind of qualitatively. This time, I'm going to do it quantitatively so that we're going to look at actually numbers. So if you can't tell from there, I'm saying going across, I got 1 second intervals. Everything's 1 second intervals. And then I have going up to here, this is -3. And going down to here, we're going to call this -2. Okay, so that hopefully you can see that. That makes sense. Let's throw out some questions. So some questions that I might ask would be something like, hey, if you have this graph, what is your acceleration at 1.5 seconds, for example? So what's your acceleration? Acceleration at 1.5 seconds is equal to question mark. So let's say there's a question like that. Well, anytime you get a graph, you look at the graph, you look at the area, you look at the slope. So in this case, okay, I have a v versus t graph. So if I want to know acceleration, let's say you don't remember. Well, if I look at the graph, oh, that's meters per second. That's not acceleration. Let's say you look at the slope. Meters per second. Per second. Hey, that's acceleration. So if I want to find, okay, the acceleration at 1.5 seconds, I need to find the slope of that piece. Well, how do you find the slope of a line? You find 2 points on that line, and then you just find the slope. So if I do 2 points on this, or if I do rise over run, my rise is I'm going from +3 to -5. So if I go, my acceleration is my change in velocity over time. Well, my change in velocity is -5 meters per second. The time is 2 seconds. So I get -2.5 meters per second. So there you have it, meters per second squared. Okay. Hopefully that makes sense. So v versus t, and you're asked to find acceleration. Well, hey, find the slope. Okay. If there was a question like this, let's say instead of find the acceleration, let's say there's a question that said find the displacement at, I don't know, we'll do 4 seconds. Okay, find the displacement at 4 seconds. So in this case, assuming we start from 0, we're starting at our 0 origin. Well, then again, you got to look at the graph. You got to look at the slope. You got to look at the area. Well, the graph is v versus t. That's not going to tell me displacement. If this was a d versus displacement versus time graph, I could just look at 4 seconds and say, oh, that's my displacement. Easy. But in this case, it's a v versus t. So the slope was the acceleration. So the area. Well, let's see. Area would be meters per second times seconds. Oh, that would be meters. Hey, that's displacement. Yay! So I need to find the area. And whenever you're doing the area, it's always the area between the x-axis and the graph. So in this case, the area of this first piece here would be 3 times 1. So it would be 3 meters plus 3 meters. So I have gone 3 meters forward. That makes sense. Okay. The second piece would be 3 times 1 times a half. So it would be plus 1.5 meters. So from 0 to 2 seconds, I would have traveled. Hopefully you can see it. This is a 1.5. Okay. I would have traveled 4.5 meters forward. Okay. Because 3 and 1.5. Well, this piece is -2 and 1. So this is actually -1 meter. So now I've gone forward. Okay. 4.5 meters. And now I'm going to start going backwards. This piece I went backwards 1 meter. And then, so really, if I was to ask you, hey, what's your displacement after 3 seconds? It would be, well, 4.5 minus 1, it'd be 3.5 meters forward. Okay, which kind of makes sense from this. Well, then from here to here, it's 1 and 2, so this is going to be, my displacement would be -2 meters. So I'm going to go back another 2 meters. So what is my final displacement? Well, I went 4.5 meters forward, 3 meters back. So my final displacement is plus, okay, 1.5 meters. So I would end up 1.5 meters forward from my starting point. But now let's say this, okay? If this was Find the distance traveled at 4 seconds. Now, distance is just how far you go. So you're going to do the same thing. You're going to look at the area, but you're not going to worry about the positives and negatives. So if I travel 4.5 meters forward and 3 meters backwards, I'm going to travel 7.5 meters. Woo! Bye, kids.